Hello, welcome to the very first drive-through sim devlog. Today in this video, I hope to go over what the game actually is, talk about some of the mechanics, the core design behind the game, and then I'm hoping to get into some actual programming and show you what I'm currently working on. Okay, so to understand the direction of this game and the mindset that we have while developing it, the whole idea started from what if there was a game where you could drive through a drive-through. That was the core idea behind it, and the rest of the game has just kind of been built around it. What we have currently is a rough implementation where the player will be able to drive up to the board, see a variety of items that they can pick from, and then verbally communicate to the game what item they would like to order. The car then pulls forward, and they receive their order, and the loop continues. If I go into play mode here, I actually can show you the early implementation of this, although it's nowhere near done. If I hold the V key right now and say some words, the program will parse what I say. So let me hold V, and I would like to order a hamburger. Now you see up in the top left, the server responded, I would like to order a hamburger. It perfectly parsed what I want to say, and that's basically the main mechanic for the game and how ordering will be handled. Now obviously, simulating ordering through a drive-through, while an interesting programming concept, isn't so interesting as a game by itself. So there is more that we plan on doing. To start, the game will support 4-person online multiplayer, so you and 3 of your closest friends can play together. But also, more importantly, the game is much more layered than just the surface level ordering system. For example, when the game is completed, we intend for it to actually be a horror/thriller game more so than just some sort of simulation. While I don't want to spoil too much about the game right now and how we actually intend on making it a horror, I will elaborate and say that the players will eventually be able to leave the car and explore the town and some of the mysteries within it. I'm sure as I make more of these videos, I'll talk more in depth about the actual lore behind the town and how we intend on making this more of a horror game. But for now, I wanted to start with something simple, and we will make the actual track that determines the car's navigation through the drive-through. So what I'm envisioning is the player will start around over here where I've got the spawn capsule at. They'll pull up to the sign, then around to this window, then they'll come over to this opening between the 2 meridians, and then out onto the street. You can actually see I already have sort of an implementation for AI car navigation, and that's through these splines over here on the non-player owned cars. And the cars spawn at one end, and then just path along the spline down to the other end. And we'll do something sort of similar over here. Down here, you can see already I've created a blueprint. It's just an empty actor. Let me stop running. Just an empty actor with a spline in it. No logic, nothing like that. What I'm going to do is I'm going to put this track down, and I will try to kind of shape out the path that I want the car to take as closely as I can get it. I'll probably speed this up and cut back to you when I'm done. Okay, so I think that this should be a pretty good shape. As you can see, um, down here, the players will start around here, pull forward, and stop right around the board here. The player will then pull up to the window and stop right around here, pull out here, and stop right about there, and then pull out onto the street where they will meet their final stop. I'm also going to move the car over to be on top of the spline. There's no real reason to do this. The car would technically teleport to the start once uh, the logic is implemented, but for sake of just like keeping the scene organized and being able to see where things should technically start, I think that this should be good. Okay, so now we need a way to communicate between the car and the track, so they have references to each other that we can access. So back inside of my drive-through track, I'm going to create a new variable, and this is going to be for the car. So we're going to call it player car, and we're making it a BP player car. It looks like it's already done it for me, but I'm going to type it out anyways. BP player car. Object reference. Yep. We're also going to want to make it instance editable so we can access it in the editor. And now if we go to our track, over here on the right, if we search car, we now have a new drop down that we can access where we can give a reference to our player car in the scene. Okay, so now our track knows about our car, but it needs to tell it when to move and how to move. And I think the best place to do that will be in the online game instance class. This acts kind of as our overarching logic state machine, and I think that this is going to be the best place for it for now. As far as I know, the only way to give values to this online game instance is by manually feeding it to them. So we'll probably do that in the level blueprint. So to start, we'll just create a variable for the uh, drive-through track, and it looks like it's also already defined the type for me, drive-through track type. That's good. And we want that to be instance editable. And then in the third person map, I will just assign it. So I will disconnect this for now, and we will do set drive through track. Okay. I will then change this type on getActor class to the drive through track, and then instead of calling this getActor of class node again, I can actually get the drive through tracks reference to the car and give it to the online game instance that way. So we can do get player car and just feed it in like this. It also looks like I made the player car replicated, so it might be best for me to also do the same for the drive-through track. Okay. So now the game instance knows about the drive-through track. So now we're going to want to create a function to actually move the car along the track. And we'll do that here. You just call it move car. So the logic for this is actually quite simple, and that's because there really isn't much logic at all. And I'll explain why. So the actual stuff that we have access to within the game instance is fairly limited, and I don't think it's sufficient for what we need to actually make the track functionality work. For example, something we'll need is the timeline node, which, while accessible in other blueprints, is not accessible within the game instance class. So what we will do is we will use our drive through track reference that we created earlier, and we will call an identical move car function within the drive through track here. So going back here, I will create a custom event called move car, and this will be what gets called back here. Now this might seem a bit pointless, but I believe that is better for the health of the code and will help references and coupling things that don't need references to each other. What that means is there are many reasons why the car will actually want to move along the track. For example, maybe the player has finished ordering, or maybe the player has received an item and now we want the car to move to the next stop. Uh, a lot of the things that the player interacts with won't know what the car is or know what the track is, and they won't be able to tell it to move the car unless we do a lot of coupling that can get ugly and create a lot of references that will make the code messy. Everything, however, does have access to this online game instance. Everything knows about it. So by making this move car function here, anything in the world can call this, and then through this, get a reference to the track and move the car. My hope of putting this here is to streamline the actual movement of the car without making everything a reference nightmare. So back inside of the track, we can actually start working out the real logic, and we are going to start with using that timeline node that I was showing you earlier. So we're going to hook this up to the play from start, and we're going to create a new float track. We'll name it alpha, and we'll make the duration 1 second. We will then add a key at time 0 with a value of 0, and add a key at time 1 with a value of 1. This is essentially just a linear graph from 0, 0 to 1, 1, and we'll use this alpha as a way to modify the position of the car along the spline. Next, what we'll want to do is actually update the car's position and rotation with information from this alpha. So to do that, we will just take our player car reference and call the set actor location and rotation node. Hook that up to the update, and what this will do is when we pass in a new location and new rotation into this, it will update the player car's location and rotation 1 to 1. So how do we actually get these new location and rotation values? Well, what we'll do is we'll take our spline reference, get spline, and we will linearly interpolate between a value of 0, which will basically represent the current node that we're on, and the distance along the spline to the next point. So for example, if we're starting at, say, point 0 here, the starting point, and we are moving to point 1, which is this point here in front of the ordering board, we'll linearly interpolate between 0 to whatever like the max distance is along the spline to this point. Let me show you. Here we will call our get distance along spline at point node. Oops. And we'll set our point index to 1. This means if we're starting at point 0, point 1 would be here. Actually, point 1 will always be this node, or this point along the spline, unless we update it, which we'll do later. From here, we'll then call our lerp node. Oops. And we will set this to the B value and leave A at 0. Here you can also see that this node takes in an alpha. This is the scalar at which the two values are weighted. And we'll just hook this up conveniently to our alpha here in the timeline. Now that we have this value, this will basically just return a value between 0 and the max distance along the spline at the spline point. And we can use this to calculate our new location and rotation. From our spline node, we can now call the get transform at distance along spline node. We'll just plug in our lerp value into the distance. We'll set our coordinate space to world, and we will expand this pin. As you can see here, we now have a location and rotation, which we just plug here and here. And we should be good for now. We'll also need some way to call the move car function And for now, I'm just going to throw it in the BP third person character class that I have. Later on, we'll have to actually change the implementation to work around our game logic, but for now, we'll just bind it to a button press. We'll just bind it to the one key. So now that we're in our player class, this actually, I can show you why this online game instance functionality is the way that it is. So as you can see in here, the player doesn't really have a reference to the track or the car, I believe. So it has no real way of telling this track, hey, I need you to move the car, or telling the car, hey, I need you to move. So what we can actually do, though, is we can get access to this online game instance, and we do it by doing this. We have this nice little get game instance getter, which we can then cast to BP underscore online game instance. And then from here, we can call its move car function, which goes in here, calls this, which goes in here, which calls all this. Okay, so now I should be able to boot the game up. And if I press the 1 key, we should see I move over to the next point along the spline. Okay, well, that was a little fast. Let me replay it. If I press the 1 key, we do get here. Now there are a few things that are odd. First, the car is in the ground, which is not ideal. So let's fix that. That's a pretty simple fix. And all I really am going to do, this is kind of just a whatever band-aid fix. I'm just going to actually get the Z value of the car, and then I'm going to go to the track, and I'm going to make its Z value identical. I could implement some logic within the actual interpolation that makes the car stay up on the road, but because we're just working on a flat plane for this map, there really is no need for that kind of overhead. So now we're back in the car. I press 1, and we come over here to the board. Now it's also a little fast. There's a few things I can do to fix that. The reason why it moves so fast is because our timeline has a duration of 1 second. Now there's a few things we could do. We could multiply this by some decimal scalar to reduce it, or even simpler, we could just make the timeline longer. You just set it for a time of 5 seconds, set the node at 5, and now we have a graph from 0, 0 to 5, 1. Back in the car, press the 1 key, and you can see the car moves a little bit slower. Now obviously, there are some problems with that fix. For example, the distance between the nodes is not equidistant, so getting from here to here in 5 seconds could be faster or slower than getting from here to here, and so on. But it's really not that big of a concern for me. I could fix it if I wanted to, but there's really no need for that kind of complication for this game. Now, one final problem, if I press the 1 key to simulate the car moving on to the next point along the spline, we stop here, and if I press the 1 key again to go to the next point, you'll see I actually teleport back to the back of the drive-through, and I'm not going any further along the spline. And that's pretty fixable. That is because here at this get distance along spline at spline point node, we're always using point index 1. If we look at the map, point index 1 is always this node here, 0, 1, 2, 3, etc. So it's always going from here to here. Now we could use some sort of incrementer to indicate the next point to move on to, or even simpler, once we reach the next point, we can simply, from our spline node, remove spline point, and we just remove spline point 0. What this does is, once we finish the timeline or reach the next node, it removes the node in the 0th position. So say we are starting from here on the left, the car will pull forward, reach this point, stop, and then remove the 0th node. What that does is it makes this node here that we're on the new 0th node, this one 1, this one 2, etc. So it reduces every node's index by 1 essentially. Testing it now, if I press the 1 key, you'll see we'll pull forward. And when we come to a complete stop, if I press the 1 key again, we now move forward to the next spot. 1 key again, and 1 key one more time. And now we're at the road. Okay, so that was a pretty rough and basic implementation, but I think it will do for now. In the next video, I hope to implement the actual ordering system so players can order, speaking to the board, their input will be parsed, and then they'll actually receive an item depending on what they asked for, and we'll tie that into our functionality that we just created here today. Thank you so much for watching today's video. I am new to this, so please, any feedback is greatly appreciated. I'm not sure if I'm going to keep doing this coding style or if I'll do more of a show and tell style later on in the future. But I had a lot of fun making this video, and I hope you enjoy watching it. Thank you. Bye-bye.